Hello, everyone. Sorry we're a few minutes late. There's a great appreciation for doing live events as we have a lot of pieces together. But we're broadcasting again from the roof of the Howey Physics Building on the Georgia Tech campus. This is our campus observatory. And assisting me tonight is John Wallum, handling telecommunications. He's with the College of Sciences. And Megan Birch, who's with GTRI, is going to help with cameras. And I am Jim Sowell, director of the observatory. And again, we thank you for joining us for this online public night. This is what we're doing now during the virus pandemic. Unfortunately, we're not able to bring people physically up to the observatory, but we're very glad that we're able to show you some fantastic images. You're not getting to look through the telescope, but in many ways, this is a nicer event for you because you're getting a longer time seeing these objects. If you were standing in line, it would probably only be for a few seconds. We're trying to always improve our presentations, and tonight we are attempting to use two telescopes and two cameras to give you different views. We will be looking at the moon, which is what we're currently on. Then we'll be going to Jupiter, then Saturn, then Mars, and we'll come back to the moon. So that is our game plan. Again, thank you for joining us. This is, for our records, November 19th, and it's about 6:40 right now from Atlanta. By the way, please feel free to shoot us an email if you're watching from someplace outside of Georgia. Uh, Glad to have such an extended audience. We appreciate that. And if you have any astronomical questions, you may also contact me. The way to find my website, the way to find my email is to go to the website, just Google Georgia Tech and astronomy, and that will put you there. So, without further ado, let's talk about the moon for a minute. It's one of our favorite objects. So, we do have a higher magnification with this setup. So, unfortunately, I can't give you the names of these objects, but if we could just adjust this view a little bit, I want to see what was up there also. We have a great view, that's good. As you can see, there are quite a few craters of various sizes, and one of the craters nearest the center also has a small central peak. But if you look at the two pairs of craters, there's a very smooth region in between, and you can see there's a crater that got partially filled in. So I can tell we're near an edge of one of the Maria. The Maria are the dark regions that when Galileo first looked at the moon, thought they were smooth because there was water on the moon, and Maria translates from the Italian meaning seas. But you can also see that there is a break between a couple of ridges, and that looks like that's where the flooding broke through. It's on the upper right. We're moving into that region. Now you can also see that we're moving to the edge between the darkness and bright, and that line of demarcation is referred to as the terminator. But interestingly, you can see some bright peaks, bright areas off in the darkness. Those are high enough up that they're catching the sunlight, even though the base isn't. And I can see that. Good. And so we've moved into another area. Now, one of the reasons that we have our public nights when the moon is at first quarter. It's a quarter of the way in its orbit around the Earth. But we always want to have the bright moon visible in case it's partly cloudy. But the first quarter moon is better viewing for us than a full moon. And the reason why is if you were to walk outside after we're finished tonight, you would see that the sun has just set, it's down on the horizon, and the angle from the sun to the earth to the moon is about 90 degrees. And so the sunlight is coming at a slant and it's casting shadows. And you can see how rugged this area is to the right. You want to keep it up maybe. And we're going to go exploring. Oh, good. Now we just found two Maria. There's one on the left and one on the right. And you can see the one on the left has only a few craters on it, whereas the region in between had a lot of mountains, a lot of craters. It's much more rugged. We believe that what happened is the solar system formed about 4.5 billion years ago. That was the sun. And then about 4.4, all the planets were forming. But it seems that from 4.4 to 4 billion years ago, there were a lot of bombardments. All worlds that have a hard surface, we see many craters all over the place. But it looks like at about 4 billion years ago, this ended. And because we've been to the moon, we've been able to date the rocks from various areas. The Maria on the moon are younger. They're in the 3 billion year range. And so they smoothed out deep craters, basins, and they smoothed it out over millions of years. And there just haven't been that many uh, asteroids and meteors floating around hitting planets anymore. Yeah, we can keep going. And I'm having fun right now. I'm telling John where to go looking. In fact, with this Maria, you can see the crater on it. It's very dark because of the shape of the and the depth of the crater. That dark shadow really jumps out. And then again, you can see the ruggedness as we come to the right edge. The and it even has some ejecta material. You can see that it looks like the impactor came from the left and it blew out some material off to the right. This is a great reason to use the higher magnification, but also to go looking on the moon. There's so much that we can find. I wanted to finish my thought. The lava that fills in the Maria is a rock called basalt, which is very dark and very runny. We do have it on the Earth, but and these Maria, by the way, are only found on the moon. We find smooth plains on other worlds, but the dark Maria, the man in the moon face, is unique to our moon. We don't. Okay. Let's do a little bit more lunar exploring, and then we'll go to Jupiter. Will be next. So you can see a variety of craters. Let's go back to the right. As we get closer to the terminator, we will see more ruggedness. You can see it's just the way the shadows are, the angles, the curvature. A very cratered region. I'm oohing and awing too. Imagine yourself as an astronaut trying to find a location to land the spacecraft. By the way, I've been reading that NASA wants to have to put humans back on the moon in just 3 years, in 2024, and they want that to include women. So you don't hear about that much, but I've seen their stated goals. Hopefully, we can pull that off. Okay, you can see the edge of the terminator is not completely straight. There's a little bit sticking out, again, due to just the shape of the surface features. Again, thank you for joining us. We just got started a few minutes ago. Oh, no, yeah, stop right there, John. So there's part of a Maria, and it's cut off, but you can see that although the Maria is smooth, it's not completely smooth. You can see ripples in the lava flows. So it was a process that wasn't perfect in what it did. But there's also a lot of, just to the left of that, I see a lot of dark. There must be a ravine or a ridge of some sort right there. You can also see that we're getting a little bit of turbulence from the atmosphere, and astronomers call that seeing. And this is still a pretty good night tonight. And as the night goes on, it's going to get colder, but the seeing will improve. Okay. About ready to go to Jupiter? Okay. All right. So this is where we're going to attempt. Are they seeing that? Okay. So this is a view of Jupiter, and we're using now the other telescope. And we're going to try to get the first telescope on Jupiter also because it will have a higher magnification. So let me tell you about telescopes for a second. We're using the two largest ones at Georgia Tech. These objects are so bright that that's overkill, though. When astronomers talk about their telescope, they have a number, and that number is the diameter of the mirror or the lens, what it's made out of. So the largest telescope on our campus is a 20-inch, or some people refer to it as a half meter. So that's a very large size telescope for a college. It's used for astronomical research, and also aerospace engineers use it to look at orbiting spacecraft to do some measurements with that. And that's the telescope we're using at the moment. And by the way, we're looking at Jupiter, and here are two of its four moons. Although when we zoom in, we'll check on that because I think in each case there are two moons very close to each other. So we might be seeing four in just a minute. So I wanted to start the larger telescope. We are using a camera setup where we have a larger field of view, and this is allowing us to find objects easier. And if we attempt to go to anything fainter, which I'm not certain we'll have time to do tonight, we would start with this larger telescope. The smaller of the two telescopes is still not that small. It's an 11-inch, and it's made by a popular company called Celestron. Celestron, Meade, and a couple other companies make telescopes for the general public. This is a very nice one. It has great optics also. And that was what we were using just a minute ago when we were looking at the moon. Now, although it's a smaller telescope, it was the way we had the cameras and the eyepieces set up that was giving us that higher magnification. But we're hoping in a minute to give you the view of Jupiter with the Celestron telescope. And Megan, anywhere close? I'm sorry? Okay, so just fighting with the telescopes. So let me tell you a little bit about Jupiter. So this is the largest planet in the solar system. Astronomers usually like to talk about the amount of mass or material that's in an object. It has more than 300 times the mass of the Earth. It's 10 times larger in diameter. But you would think because of that, it would be a very slow rotator. It takes us 24 hours to spin on our axis. It only takes 10 hours for Jupiter to rotate, and that's actually the fastest planet rotation in the solar system. Now, Jupiter and the outer planets, Saturn, Uranus, and Neptune, are very different from the Earth. They do not have a solid surface to land on. It'd be like trying to land on a cumulus cloud. In fact, when we look at the views of Jupiter, we're going to be looking at cloud tops. And they're going to be different colors, and that's because of different depths, different amount of heat and motion, and also a little bit of the composition. Interestingly, on Jupiter, because it is rotating, spinning so quickly, all of its weather is east-west. And so it looks like train tracks that are parallel to each other. There is no north-south motion. They don't get cold fronts coming from the North Pole toward the equator. Now, Jupiter, and Galileo discovered this, also has 4 large moons. In fact, the largest one, Ganymede, is larger than the planet Mercury. Another one, Callisto, is just slightly smaller. And then 2 other moons, Io and Europa, are about the size of our moon. Galileo found these 4, and this was an important astronomical observation because he ultimately realized that these were moons and that they were going around Jupiter. They were not orbiting the Earth. This was one of 2 of his major observations, which was helping to show that heliocentric, the sun-centered solar system model, was correct and not the one where everything was going around the Earth. The 4 moons, the one that's in the news rather regularly right now is Europa, which is the second closest of the 2, because this is the one where many scientists are hoping to discover bacterial life in the waters. The waters are not on the surface, but underneath an icy layer that's about a half-mile thick, is what the guess is. And then the ocean underneath that, though, is maybe 50 miles thick. It's substantially deeper than what we have on the Earth. So that one's in the news, and we have scientists here at Georgia Tech which are working on programs for that. And we have a department with planetary astronomers here. They're in the Earth and Atmospheric Sciences department, several of them, and we also have other engineers that are working with spacecraft that are studying the planets. So planets are actually a strength of Georgia Tech. Other moons, the nearest one, Io, is the one covered with volcanoes, and we're almost ready to go to the higher magnification view. And when you guys feel that it's ready, go ahead and move it in. Uh, I would like to still see the moons. I think we have actually more than just two moons being seen right at the moment. So I can see the image that we're about to give you, and it's nice to be able to jump up to these bigger disks. You know, we really didn't begin to see these worlds well until the Voyager spacecraft in the 1980s. And that was when it first got to Jupiter and then later to Saturn. And, now we've had quite a few spacecraft uh, traveling by or orbiting or even landing. But when I was an undergrad, the views were typical of what we had on the right. The moons were going to be small dots, and we didn't have much information about them. So we've really been living in a wonderful age of discovery. And so now we're on the higher magnification. Pretty good. And there's we got to remember not to walk around too much because we cause a little bit of vibration. So how many bands can you see? Two or three. We're seeing, John feels he's seeing two or three. And when we were getting the telescope focus before we put the cameras on, Megan said she could see the red spot. Red spot is difficult to see these days. It's rather pale and it's a little smaller. We know that it's been there for at least 300 years. We don't know if it's been around for 3 million or just 400 years, but it's always a pleasure to look at it. It's a hurricane that's sitting there spinning in about 4 days, sitting between two different bands of weather, one of which is going in the opposite direction. Another great aspect about Jupiter. So, are we able to try to brighten the moon or not? Okay, we are. We're going to go to that view. Okay. All right. Well, it might be that we really only have two moons out tonight. I know that moons can be behind the planet and or in front, and so maybe it's just our timing. I'm glad that well, you can go to that when you're ready. So, guys will have to tell me what they were doing, but whoops, go back to what you had, Megan. The zoomed in. Could really make out the view a little bit better. Wow, you can see the darkness. And is that the red spot right there in dead center? Okay, that is the red spot on the bottom. It's a nice view, and that's quite good. I'm glad we were able to get this for you. What I was going to add was Jupiter and Saturn are beginning to be gone. You can probably see them through the end of December, but you can tell that they're already beginning to get further over into the toward the western sky. And but each month we'll have the moon. We will continue to have Mars for a few more months, though. So this is fantastic. So my audience, I have to let you know that some of my Georgia Tech students in my two astronomy classes are watching this, and I will be giving them extra credit, but I have to make certain that I can tell that they have watched. And so the technique that I've used is I'm going to give out a keyword, and I want my Georgia Tech students in my class to send me an email immediately with that keyword in the subject line. That's all I need. Just put it in the subject line. So tonight's words are Milky Way. So Georgia Tech students in the subject line, Milky Way, and second, I know my cell phone will start vibrating with all of the emails that I'll be getting. Okay, so Are we soon going to be able to go to Saturn? So we're going to leave it here for a minute on Jupiter, but Saturn's next on the list. Okay. Uh, so we're in the process of just moving the telescope. It doesn't have to go too far. If you haven't been outside and looking, and hopefully you have clear weather, you can see the moon right now, the crescent, and off to the right, the very bright object is Jupiter. The moon is the brightest object in the sky right now, followed by Jupiter, and is the third brightest. In between and up a little bit, significantly fainter though, that is Saturn. And if you were with us last month, it was fantastic. The moon wasn't as far along, and we had a beautiful equilateral triangle. But now we have this clumping again, and you can see aspects of the periodicity of the motions up in the heavens. So the moon, beautiful sight with the naked eye, with a small pair of binoculars, you can make out craters in the Maria. And then if you point it at Jupiter, and as long as you put your elbows on something to steady you, you can actually see the 4 Galilean moons also. Now we're going to go to Saturn, and unfortunately, you do need a telescope to see the rings. Galileo never got to see the rings, but he could tell the planet was kind of distorted. He referred to the planet as having ears. We would probably say it looks kind of like a football maybe today. So you have to have a small telescope, get up to a magnification of about 50 times before you could begin to make out the rings. So Saturn is second only in many ways to Jupiter, except for the rings, of course, which are fantastic. So Saturn's about 100 times the mass of the Earth, 9 times the diameter, and it spins in just a little more than 10 hours also. By the way, both Jupiter and Saturn, we now know, have more than 60 moons, and who knows, it might be 600 as we have more spacecraft that can orbit these worlds and really begin to take them in and to see that. Now, we will hopefully see a few moons around Saturn. They are not as bright and as prominent as the Jovian moons are, but there are definitely some very interesting moons around Saturn too. So, are we about ready for Saturn, Megan, or another minute or two? Okay, so uh, as you can see how large Jupiter is in our field of view, it means we have a very small view on the sky, and we have to make certain our telescopes are really dead on, and they're not always quite that way. But believe me, these are worth the wait. We will not be having a public night in December because the moon at its best is too close to Christmas. Our next one will be the third week of January. I think it's around the 21st. And Jupiter and Saturn will not be with us then. So that's why glad to show it to you tonight. When we get to January, though, another beautiful object is in the constellation Orion, which is going to be rising in an hour or two. So, and I now see Saturn in the camera view, and whenever we're ready to, there it is. Okay, wow, wasn't that worth it? This is fantastic. Saturn, and it's great for me too, not just because I love this so much, but here's a little bit of history. So Saturn's orbit around the sun is about 30 years, and so there will be times when we see the rings really well, and then times when it's edge on, and then really well again, except this time we would be looking from underneath instead of from top down. So when the Georgia Tech Observatory was built, it was about 2 years before Saturn's rings were seen edge on, and the observatory was built about 13 years ago. So it's only been the last couple of years that we, from this observatory, have actually had these great views of Saturn. So I remember the views that were not so spectacular, and now it's a real treat for us. So I want to mention the rings a little bit in that they look like they're solid. They look like the kind of washers you would put under a screw when you're putting a screw and bolt together into some metal. That is not the case. These rings are made out of billions of little tiny, about BB size or golf ball size particles, and they're covered with ice. And we've now gone to the other camera with the higher magnification. A little bit of atmosphere still moving around a little bit, but and you can actually see the image, I think, has been flipped from one camera to the other. But these ring particles are like tiny moons. They're all in orbit around the planet. And if you've got a Hubble picture or one of the orbiting spacecraft, you could really see, or Voyager spacecraft, you could see grooves in the rings. You could see gaps. We would normally say they look a lot like a phonograph record. That is due to moons. Sometimes the moon is actually where the gap is, and other times the moon has an orbital resonance and can cause a tug and clear it out. We have a highly magnified view, which there it is. We're trying to keep it in, so there's a bit of bouncing due to the building and due to the atmosphere. But it really shows the structure. By the way, there are a lot of amateurs who love to do astrophotography. We're beginning to try to get some great pictures from the observatory, but you can also videotape objects, kind of like what we're doing, and there's processing that can stack these images to produce one beautiful image, and it can be quite stunning. So we're trying to get these kind of pictures out, and also to do that. But again, you can catch moments when it's stationary, and you can maybe was making out a little bit of structure, a little bit of bandedness. So we've kept the brightness up, so we're not really seeing, or we've kept the brightness down actually, not seeing the moons. We have to crank up the gain, and that will overexpose Saturn in order to see the moons. And these moons would just be dots. So I think we'll just stick with the beautiful image of Saturn. And in a moment, you need to get ready to go to Mars. Okay, so good. I want to thank the team again. We're doing exactly what we had scripted. We have one telescope on one of the featured objects, and the other one is slewing over. And this is a longer slew. Mars is the bright object about halfway up in the sky toward the east, and you can make out that it has a little bit of an orange color. It's not quite as bright as Jupiter. So again, if you're outside and just looking up, that is it. Now, Mars, unlike the other planets, because it is so close to us, it does change its distance from being very close to being very far away, which can cause its brightness to change and also its size when we're looking at it through the telescope. And Mars was at its closest to Earth about 5 weeks ago. So, but we had beautiful images 4 weeks ago, and I'm looking forward to tonight. It might be just a little bit smaller, but it should still be some lovely views. But, you know, each month then it's going to dramatically change. It will get smaller. And when Mars is not close to us, you really can't see any structure on it. You just make out that there is an orange disk. So we're working toward it. Of course, there's no reason to ever rush leaving Saturn. Those rings are so spectacular. By the way, all of the four Jovian planets have rings, but the other three, the rings are just not like Saturn's. Jupiter's faint rings are more like smoke. Uranus is exactly the opposite from Saturn in that it has very narrow rings. Excuse me, very narrow rings, widely spaced but very dark. And Neptune has a few narrow rings too. In fact, they're not even complete. They don't go all the way around. So there's something about the rings that all the Jovian planets certainly seem to have it, and yet a variety of different types. Okay, so I can see that we are acquiring Mars. Again, it's just trying to get the telescopes and the atmosphere to behave. But again, I really want to thank Megan and John. They are fantastic. Uh, I'm sitting here just getting to watch and to talk to you. And again, I greatly appreciate that you've joined us. And are we about to show Mars? Okay, we're on Mars, and we'll you can certainly see there's a disk. Now, we're going to try to zoom in some to improve the image. We have the larger telescope is moving over toward it in a second. Now, with Mars, with the size that it is, there's not a lot of structure on Mars, but what you see is you can see some darker regions, and that is real. It's not just an atmospheric effect. The Mars has the very orange surface due to basically rust. Oxygen is combined with a lot of the minerals, but there are darker regions, and they actually change every other year because of giant dust storms. So they can cover up the darker regions, and other times it might open up different ones. Now, with these ground-based telescopes, we can only really zoom in so close. But Mars, there is a great deal of study going on. You know that we've put 4 rovers, and the rover Curiosity is still functioning. The others worked for a long time. Within the last couple of months, 3 different spacecraft have been sent to Mars, one by the United States, and I'm sorry I forgot what the other 2 countries were, but it's definitely an international effort. I think we still have 6 orbiters around Mars that are still working, and we're about to give you a beautiful view with the orange reddish color. Oops, we had it for a split second. So, but it's a world that's being studied very regularly, and it's partly due to the fact that it gets close like this about every 2 years, and so we're able to send a spacecraft. They don't have that far to travel, that much time, and they're able to get there. And we've really figured out how to do this in such a way that we're very successful at it. Okay? So we're about to get the second telescope on it. Just although we thought that this could work really well, we did double the technology because we're using 2 telescopes, 2 cameras, setups, 2 different bits of software, even I believe, in order to get this to you. But after we see Mars and we have some beautiful views of it, then we will go back to the moon and finish up the night by looking at it. It's not working. So something has stopped for a second, and try to get it going. Uh, I mentioned that at Georgia Tech we have astronomers dealing with the planets. I also want to say that in the School of Physics we have astrophysicists, which are dealing with the other spectrum, the other end of the universe. We have some that are dealing with the early universe, not the Big Bang, but what really formed after the universe began to make objects. What were the first objects? What were the first stars and galaxies like? How did black holes begin to form that we think are at the center of these objects? We also have astronomers and astrophysicists dealing with gravitational waves, the LIGO experiment, where now we're able to feel the ripples in space to get an idea of what was happening instead of using light. And we also have astrophysicists that collect particles, astrophysical particles, neutrinos, other kinds of particles, gamma rays, although technically light acts more like a particle. And these are usually coming from very energetic sources also. And the astrophysicists, their workshops are all around the world, from literally the South Pole to a variety of stations scattered throughout the world, and they'll even use spacecraft. So if you're in high school and you're very interested in astrophysics and astronomy, Georgia Tech can be a great place for you. We also have an aerospace engineering department, and there are many engineers working on spacecraft. And actually, there's a great deal of NASA grants and projects here at Georgia Tech. So really, do put us on your list, and certainly if you're in the area, someday you'll be able to visit the campus again and see us. And I certainly hope we'll be able to have public nights again with people getting to look through the telescope. Glad to show you these kind of views. So are they? So here we go. Finally, a more magnified view of Mars. I can certainly see some dark streaks. Unfortunately, the atmosphere tonight just is not quite as stable as last month. You can see how the planets are jumping around. But just relax your eye and look at it, and I definitely see a horizontal dark streak across the top. It's great to be able to see some structure like this. There is a polar cap. I'm not quite certain where it is, but it's great being able to see this and to see our friends like this. This is one of our nearest neighbors, like a next door neighbor, to go out and to see this. And again, though, I'm highly encouraging you to go out and look up at the sky. We're putting one telescope back on the moon, and we'll get to explore it for a little bit more. But even here in downtown Atlanta, we're able to see some other constellations, some constellations straight overhead. And hopefully, you live in a slightly darker location and that you can see these objects. But we're very pleased that we're able to give you views like this. And you're probably watching it from the warmth of your home. We are out in the cold right now. It's probably about 47 degrees, I think is what was predicted. So we're, let's see, we're putting a second telescope back on Mars. And like that view, we're able to show it. There we go. Orange color, just a little bit closer to what I'm used to seeing. You can see the orientation of the telescopes are a little bit different because now that horizontal streak is more vertical. But that's definitely real. You are seeing the surface of Mars. Mars really has no clouds. It does have an atmosphere, a very thin one. So as you look down upon the surface, you're really seeing the surface more so than if you were to look at the Earth, where you have half of it obscured by clouds. So, beautiful view there. And we do have one telescope that's heading back to the moon now, and we'll get to that in a minute. By the way, Mars does have two tiny little moons that we believe are captured asteroids. I've never been able to see them through a telescope. You're going to have very fine eyes to ever make that out. So glad we could tell you some about these moons. Also, I wanted to add with Saturn, I wasn't able to show you the moon Titan. Maybe we will try to give that one try. But Georgia Tech and the astrobiologists have been celebrating a Titan week here at Georgia Tech. Have an eminent scientist visiting the campus. And so I think the Google Titan and Georgia Tech, or I think it's Titan at Tech, you can get the information, and hopefully there's still some activities and talks for tomorrow. Again, there is a lot of astronomy and astrophysics occurring at Georgia Tech, and we do appreciate you tuning in, and we love to show off what we can. One advantage of astronomy is that we really do have fantastic pictures. And so I think we're about to go back to the moon now. Love to end on really spectacular views. And, we never know. Our first two public nights, the ones in August and September, were completely clouded out. We had a beautiful night last month, and we got this one. And so we just don't know how the weather is going to be for us. Very thankful for this. In fact, I must say that the Jupiter and the January and February public nights often are clouded out. So we're very thankful that you're here and watching. So again, now here's a great view of the moon. We've got a Maria on the right, a Maria on the left. You can also see in between some highlands, a variety of sizes of craters and shapes. I mean, look at the shape of the one that's to the left. It's kind of looks to me like it's like a face. And there's another one right below it that has been flooded slightly, and it looks maybe kind of like calipers. So it's so crater on top of crater on the moon. It's a heavily cratered world for certain. Let's go down maybe. Okay. Again, a very heavily cratered area. We're on the Terminator. That's a different Maria. You can kind of make out that the colors are slightly different. You can certainly see brightness differences. There's one crater with a very bright size. When you look at the moon like this, you have to just take your time and look at one section at a time. And even in a view like this, there's a beautiful crater on the left edge. It's kind of small. There are some mountains in that smoother Maria region on the right. So just a great many places to visit. Now, I would like to go to the other telescope picture for a second. So even though it's the larger telescope, you can get a better view of the moon, a larger view of the moon, and really begin to make out features. And now it's so easy to see a few of the Maria and how smooth they are. And as the moon continues to go through its phase, the next several days, you'll be able to see more and more of the Maria. But you can also make out that there are definitely cratered regions. Again, this is a kind of view you could see with a pair of 10-power binoculars. Just really have to get yourself steady, and you'll do fine with that. So a beautiful, fuller view. In fact, astronomers usually do like giving you a larger view. You can also see the atmosphere isn't as much of a problem, but that's a great view. Let's go back to that, John. Yeah, to that one. So we're going to jump back now to a magnified view. It's just such a delight to look at the moon. And I'd say just let's go wandering, John. Head anywhere you want. And again, that was where we started. That's a couple of craters, but look at that smooth area in between. And now there's a filled-in crater. You could tell it had been deeper at one time. And again, I find it amazing that some craters have a very bright rim The sunlight is just reflecting at exactly the right angle to make it very bright. Yeah, I love that filled in crater. So kind of has its own Maria in the center. Let's keep going up, and soon we'll finish. Yeah, that other Maria, go to the right. That very dark crater really jumps out at you. Some of these the dark regions, just because of the angle and the shape of the sunlight. Yeah, those. And then there's also the right edge of the Maria. You can see is not completely smooth. There's a ripple in the lava. So let me see if my colleagues feel there's anything else I should mention. Um, I think we've had a fantastic night again. Uh, then thank you for joining us. So we've looked at the moon, uh, Jupiter, Saturn, and Mars. We will be back. Our plan is in January, and it'll probably be the moon, Mars, and the Orion Nebula. So again, if you happen to have any questions or any comments, again, my email address you can find by Googling Georgia Tech and astronomy. Hope you've had a great time, and this will be backed up. It's taped. It's on our YouTube channel, as have been the previous public nights that we've had, and we'll try to make certain there's a few other videos on there, like from the solar eclipse. So again, thank you very much. We really do appreciate you sharing your time with us. So, I'm sorry? Yes. So I'll give my students the word one more time. So that's Milky Way. And good. So again, thank you, John and Megan. And from the Georgia Tech Observatory, this is Jim Sowell. Have a great night.